Okay, I think we shall start now. Make sure that my voice is audible or not. And let me present my screen. My screen is visible or not. I think I am audible and my screen is visible, right? Okay, so welcome to the live interaction session of week 8, like computer integrated manufacturing course, which is instructed by Professor J. Ram Kumar and Professor Amandeep Singh from IIT Kanpur, and myself Chinmayi. I am a PMR scholar from IIT Madras. So basically, in this week of week 8, the assignment questions are being discussed on flexible manufacturing system, industrial robots. So we'll see the questions and we'll try to discuss all those questions which are being solved in previous years as well. So basically, like if we talk about flexible manufacturing system, so what is meant by flexible manufacturing system? So it's a manufacturing concept, we can say, which allows production to adapt when facing changes in its like requirements. So that required changes could involve, we can say, amount of product being produced or a new product part which is needed. So the changes could be either like predictable or unpredictable. So the main key takeaways for flexible manufacturing system is that it's concept that allows the machines and other components to adjust rapidly when required. And moreover, you can say like these systems will typically involve a center control computer or say production machines and material handling systems. So different types of flexible manufacturing system based on their level of flexibility, type of operation, and like number of machines used are there. So basically, how does that flexible manufacturing system works? It like that system could be machine flexible, material handling flexible, or operationally flexible. We can say. So if we say that world is becoming like closer than ever with the advancement in technology and trade, as we know. So this generates stress on companies engaged in like those works. So that demand for certain products has like that companies now have to face the challenge with innovative, high quality solutions like which is produced in large numbers. Some of them have heavy scope for customization. So this has led that flexible manufacturing system like in our picture. So we can say highly automated machine cell consists of a group of like processing stations that interconnected by an automated material handling and storage system, and which is controlled by an integrated computer system. Okay, so this is the main principle of flexible manufacturing system. Like so, where like say for example, it consists it like is the main principle which is like that flexible manufacturing system or FMS relies on that no manufacturing system can produce an unlimited range of products, or we can say an FMS is capable of producing a single part family or limited range of part families only. So that is the main overview of we can say flexible manufacturing system. Okay, so like if we say that flexible manufacturing system, then like numerical control and then CAM, that is computer aided manufacturing, and robots. That middle one, that common word will be the type of automation which is needed. So that is the main overview of that flexible manufacturing system. So first question which was given industrial robot. So let me first talk about that what is like meant by that industrial robot. So it's nothing but an automatically controlled, reprogrammable, multi-purpose manipulator, which is programmable in like three or more axes, which may be either fixed in place of like mobile for use in industrial automation applications. Okay, so like industrial robots are important because that robots can substitute for like humans in hazardous work environment. Then consistency is there and accuracy not attainable by humans, though, and then can be programmed. Robots are controlled by computers and can therefore be connected to other computer systems. So that is the importance of being introducing the industrial robots. Okay, so basically, we have seen the main definition of industrial robot and what does it mean about that industrial robots. So, industrial robots are advanced machines designed to perform variety of tasks. We can say in manufacturing environments. So, they are equipped with specialized tools, sensors, softwares, which like finally allow them to carry out repetitive, precise and dangerous tasks like where human we have seen that has in hazardous work environments, so the robots can substitute for humans. So in that cases, even itself, so with high accuracy and efficiency they can carry the work, and like can be, so here industrial robots options are given as can be reprogrammed. Okay, anyway I'll be uploading it later, so anyway I can send it, no problem, I'll send it. Okay, anyway, so the options are given as can be reprogrammed, are controlled, so can be reprogrammed. So this, if we see like say about this point, so industrial robots are designed to be flexible and adaptable to changing manufacturing requirements. Okay, so obviously it can be reprogrammed to perform different tasks, like operate at different speeds, and even like what we can say, like it can interact with different machines and equipment. So this makes them, we can say, an ideal solution for manufacturers who need to switch between different products and process quickly and efficiently. So yeah, obviously it can be reprogrammed, and that option B is given as are controlled by computers and can therefore be connected to other computers. So here if we say this point, so industrial robots are typically controlled by a central computer system. So basically it coordinates their movements and operations. So that system can be connected to other computer systems within that manufacturing environment itself. We can say, for example, as we have seen that in enterprise resource planning, that is ERP systems or manufacturing execution system. So to enable that real-time data exchange and monitoring. So it allows manufacturer to optimize their operations and also improve overall efficiency. So obviously, so that's the reason it is controlled by computers and can therefore be connected to other computer systems as well. Then the C options that can substitute for human in hazardous work environments. Already we have discussed about that. That is there, like if we say about these points, yeah, so like for example we can say robots can be used to handle toxic chemicals, operate heavy machinery, or perform tasks in high temperature environments. So by using robots in these situations, manufacturer can reduce the risk of workplace accidents and injuries. So here we can say that the industrial robots can be reprogrammed, are controlled by computers, and can therefore be connected to other computer systems, and also can substitute for humans in hazardous work environments. So the correct option will be option D, all of this. Okay. Uh, so coming to the next part. Now, if we talk about the robot anatomy, or like robotic system, so like uh, basically this robot which is given in the pictures, or that is actually used for pick and place. So it's the one, that one part is there that is called like wrist, we can see. So there you can have pitch, yaw, and roll. So basically what it does, that role is like given for, it can pitch, it can yaw and do yaw, and it can roll. So roll is basically for rotation, pitching that is moving up and down, and yaw that is moving left and right. So those things are done by wrist. So in combining with that elbow, where there is a rotational joint itself, so it can move this up and down, and shoulder is also having that same work function, that is doing that can move its up and down. So these all can rest on the waist, so which can rotate finally. So basically what it happens, if we see the robot anatomy, there like it consists of even that one is there is manipulator, then it's like end effectors, then robot joints, kinematics, those are there. So anatomy of industrial robots deals with that assembling of outer components of robot, that is that wrist, arm and body. And before that into that robot configuration, some key facts are there, that is end effectors one is there, then robot joints, then manipulator and kinematics, which I have already told. So then that there in that end effector, what is that, that hand of a robot is called as end effectors. So, like grippers and tools are the types of end effectors, we can say. So, grippers are used to pick and place the object, and the tools are used to carry out operations like spot welding and spray painting in art on a workpiece. So, it's basically it's carrying out the operations, like used to carry out that operations. Okay, then one question is given as the hand of the robot is considered as. So we have seen that in like in industrial robotic system, so end effector is specified tool or device that is attached to the end of the robot arm or manipulator. So end effector is responsible for interacting with the environment or performing tasks as grasping, manipulating or assembling parts. The hand of the that robot is like an end effector, we can say, as it is designed like to mimic the function of human hand, we can see. So it basically interact with objects in similar way itself. So here the right option will be end effectors. Okay, so the hand of the robot is considered as end
Great.
effectors. And then okay, so the another part is joints. Okay, that is their robot joints. So joints in an industrial robot basically are used to like perform the operation as sliding and rotating the movements of component. Okay, so if we like say this as like manipulate even like in that is uh, fill in the blank is given as in a robot or developed by the integration of links and joints. Okay, then coming to then if we say about this question, then we need to have an understanding on manipulators as well. So like manipulators in a robot basically developed by integration of links and joints. So in the body and arm itself, it's applied for moving the tools in work volume. So it's basically used in wrist to adjust the tools itself. So the thing is that when a manipulator consists of joints and links. Okay, say for example, if we draw here, so so basically those are links. This is also link.
Bait
Okay.
ka na ha sa ta. अल्लाह जी कहने वहाँ बैठता नहीं हाथ लीजिए था क्या कर तुम्हें बैठता ओके
So The thing is that here, if we say that these two are the links, and then is the joint. So basically, joint provide that relative motion. Links are rigid members between joints, and with like there are various joint types: linear, rotary, and each joints provide a degree of freedom. So this is basically that robot manipulator even consists of two sections, that is body and arm. One is that for positioning objects in robots work volume, and another one is that is like disc assembly for orientation of the objects. So here question, according to the question, so in robotics, manipulator is a mechanical device consisting of a series of links and joints. So which allow it to move and position objects in space. So manipulators are the basic building blocks of most robots, we can say. And they are developed by the integration of links and joints. Okay, so link is a rigid component, as we have already talked about that, of manipulator, which connects, we can say, two or more joined together. So even we can refer this figure also. So link can vary in of that they can be made of metals or plastics or materials, other materials. So a joint is a mechanism which connect two adjacent links in a manipulator. So and like finally it allows, we can say, to move relative to each other. Okay, so the that is the thing of that manipulator and the working principle of that manipulator. So here it is given as the fill in the blanks in a robot are developed by the integration of links and joints. So the right option will be manipulators, right? Then coming to the next part. Okay, so here, like if we say about that first slide. Okay. So, okay, okay. Then coming to the joints, like types of manipulator joints. So there are different kind of manipulator joints are there. That is translation motion. So linear joints are there. That is called also type L. Then orthogonal joints. That's type O. It's written as like that. And then rotary motion. So rotational joints, twisting joints, revolving joints. So basically, like linear joint, if we explain, is like that. If we like draw it here, So if we say as this one is input link, this one if we say as output link, so this will be the motion that is linear, right? Joint motion. Okay. So this one is the type of linear joint. That joint motion is linear to that output link. Okay. And if we draw it as like, say for example, another one I'm drawing it here. So this can be joint motion, the direction of that joint motion. Okay, and this is the output link. So you can see from the figure due to that with the joint motion, that output link is perpendicular. So it's orthogonal joint, we can say, right? Okay. So basically, those are the few types of then rotational joints where that joint motion and output link in that rotationally like in that motions, and then twisting joints where also that those are the types of that rotational rotary motion joints in rotate like and joint motion and outlink, that joint motion in like rotary kind of thing we can say, and then out that revolving also in that joint motion is in rotary motion joints. So those are the basically types of joints like manipulator joints. Okay, so here one question is given as fill in the blank, provide relative motion in a robot. So in robotics, like joints, we have seen already, we have discussed about that are mechanical components that allow relative motion between links in a manipulator, between that adjacent link in a manipulator, we can say. So joints provide different degree of freedom to the robot. So finally, what it does, it allows to move and position objects in space. So like several types of joints we have seen here, like now rotary and in like translation in rotary and translational motion joints we have seen. So here it is given as provides relative motion in a robot. So basically what it does, that links actually in what it's a like rigid component that connect two or more joints together. So they do not provide that relative motion by themselves, but from the structure of that manipulator robot links that joints only give that relative motion in a robot as we have seen here. So the right option will be joints. Okay. Which of the following manipulator joint is used in rotary motion? So just now we have talked about the different types of joints, and like those are translational, right? One is linear and one is orthogonal. So linear joint, orthogonal joint we have seen, those are given translucent motion, right? And then what is this, which of the following manipulated joints is used in rotary motion? So the remaining option is twisting joint. This will be the example of that manipulated joints which is used in rotary motion, right? It's like twisting joint, also known as maybe a revolute, that twisting joints like is like that rotary joint also we can say that is type of that joint, that manipulated joint which allows for rotary motion we have seen here. So enables that robot to rotate one link relative to the other around a common axis. So this is the correct option for that. And which of the manipulator following manipulator joint is used in translation motion? So linear joint, rotational joint, revolving joint. So rotational joint, revolving joint we have seen, and twisting joint, those are the joints which is used in rotary motion, and linear and orthogonal we have seen here which is used in translational motions. So the right option will be linear joints. Okay. Okay, now if we talk about robot body and arm configurations, so like basically there are five common body and arm configurations are there for industrial robots. So one is articulated robot, then one another in is polar configuration, then selective compliance arm for robotic assembly, which we call as SCARA as well, and then Cartesian coordinate robots and delta robots. So basically, what is the application of robot body and arm configuration? This is nothing but like the function of that body and arm assembly is to position the end effector, that is we have already seen end effector as gripper or tool in space. Okay. So, if we talk about articulated robot, it actually a similar configuration of our arm, that is human arm. So it is like the principle of working this articulated robot is nothing but as working principle of general configuration of that human arm. Okay, and then polar configuration is like consists of sliding arm, that is L joint, which is relative to actuated relative to the body, so which can rotate about both vertical axis and horizontal axis. Okay, so and SCARA robot is there also, so that is like similar to jointed arm robot, so except there is vertical axis one which is used for the shoulder and elbow joints to be compliant in horizontal direction or vertical, like for vertical insertion text. So another one is that is Cartesian coordinate robot. So it basically consists of three sliding joints. So two of them are orthogonal. So in or actually it's like rectilinear robots and XYZ axis are there in the robot. So in that three sliding joints are there in that Cartesian coordinate robot, which is showing in the figure itself. So among them, like in three sliding joints, two of them are orthogonal. Okay, so the question here is given as how many orthogonal joints are there in a Cartesian coordinate robot. So right option will be 2. Okay, so basically those are the five types of robot body arm configurations. Articulated, that is the representation of human arm configuration. Polar configuration is there where like it's like basically consists of sliding arm, so which is actuated relative to the body, and then another one is SCARA, that is selective compliance arm for robotic assembly, that is SCARA, that is nothing but like it consists of to like similar to the jointed arm robot, except the vertical axis are used for shoulders. So, and about both like a vertical axis and that horizontal direction for the vertical insertion task. So that is SCARA. Then another one is Cartesian coordinate robot, which we have seen right now in the figure itself, and then Delta robots. Okay, so it consists of three arms attached to an overhead base. So basically each arm consists of two rotational joints. The first of which is powered and second one is unpowered. So that is the basic overview of Delta robots. So those are the five uh, robot body arm configurations available for industrial robots. So coming to the next part, that is wrist configuration. So like basically wrist assembly, we have seen that uh, roll, pitch and yaw, that is like there we have seen initially in the initial slides. So wrist assembly basically is attached to the end of the arm, so end effector attached to the wrist assembly. So what is the working like function of that, or use of that wrist assembly? It's nothing but it's used to orient the end effector. So body and arm, which determines global position of that end effector. That is how it works. So if we say as that work volume, which is like it is nothing but that like three-dimensional space within which robot can manipulate the end of its wrist. So also it sometimes it's called as work envelope also. So work envelope or work volume. So it's determined by number and types of joints, ranges of joints, sizes of the joints. So which basically decides the work volume or work envelope. So where one question is given, so to answer this, then so what we have understood from that work volume of a robot, which refers to the three-dimensional space within which robot can manipulate the end of its wrist or end effector. So total volume of space that robot can we can say reach and work within. So size and shape of work envelope depend on number and types of joints in the robot. So and the length and shape of the robot's links. So work envelope, that's the reason is an important consideration. We can say while selecting the robot for particular application, as robot like must have that work envelope that is large enough to reach all the points in work area and performs the required tasks. So need to be configured like to avoid say for example say like we can say to avoid obstacles or work within a limited space. So that is the overview of work envelope. So here the question is given as the three-dimensional space within which the robot can manipulate the end of its wrist is known as, face it, that work envelope, right? Okay. Then coming to the next part, so yeah, here like notations are basically they are given as joint notations for like those five arm and body configuration which we have talked about and we have seen that that is articulated polar skara and Cartesian delta. So the notations are used and work volume also is used. So for articulated like the work volume used at partial sphere is used as work volume, and then polar partial sphere, then scaras like cylindrical work volume is there, as notations and joint notations are given in standard, those are there, and Cartesian coordinates rectangular solid for delta type like hemisphere is given as work volume. So those are the joint notations for those given 5 arm and body configurations which are available. Then like basically the drive system is required, joint drive system which use the motors to actuate individual joints. Say electric joint drive system is there, hydraulic joint drive system is there, then pneumatic joint drive system is there. So that in electric like joint drive system, it uses electrical motors to actuate individual joints. Then in hydraulic, it use hydraulic pistons and like rotary vane actuators. Then in pneumatic, like limited to smaller robots and simple material transfer applications are there. So those are the overview of joint drive systems. So in the another part is the sensors in robotics, internal sensors, external sensors. So used in industrial robot, internal sensor does like basically it is there to use to control position and velocity like of manipulated joints, and external sensors are there to use to coordinate the operation of robot with other equipment in work cell. In that also there are different kind of their tactile sensors there, which touch sensors and force sensors, like proximity sensors are there when object is close to the sensors. That time use machine vision sensors basically where it does use, say for example for complex texture surface textures are there, that time it's very difficult to use the other sensors which are available. So for that machine vision sensors, using that camera captures the images and with help of lens and lighting system. So camera captures the images, and from extracting those captured images, like the data has been processed, and it gives that wherever the defects are there, it gives the results by doing the edge detections and other algorithms which are available as image processing and there. So that's how that machine vision analysis does that their job. So and other sensors are also there, then temperature, voltage sensors. So basically the working like or functions of sensors in robotics is this, that which I'll discuss. So now like we have seen that body arm configuration, manipulators, sensors, internal or external both sensors. Now that it's time to talk about that robot control systems. To answer two questions are there on that robot control system. So if we talk about that robot control system, so like limited sequence control, which pick and place orientation, some using like mechanical stops to set position. So point to point control is there, with continuous path control is there, intelligent control is there, which like behaves the it seems like intelligence, say for example response to sensor inputs and make decisions, communicates with humans. So that is how that robot is being controlled and robot control system works. So like here comes that programmable logic control. So what it does, like a we can say digitally operating electronic apparatus is there, that is programmable logic control, that is programming that uses the programming memory for internal storage of instructions for implementing specific functions such as logic, sequencing, timing, counting, then arithmetic to control through digital or analog modules. So different like various types of machines or process. Okay, so that is the overview of that like programmable logic controls, and the components of programmable logic control or PLC is that uh, we can say power supply, input module, then processor, then output module. It's their programming devices, laptop, USB. So from sensors to output, there are the components there in between that. From sensor to output, in between that there are the components of the PLCs are there. So that is input module, then power supply, processor, programming device, then output module, and lastly to that output input. So this is how that it works. Like power supply say provides a voltage needed to run the primary PLC components. So input modules, it provides signal conversion, like an isolation between internal logic or level signals inside PLC. Then processor is there, which provides intelligence to command the activities of the entire PLC systems. Then programmable device is there, which is used to enter the desired program that will determine the sequence of operation and control of process equipment or driven machine. So those are the basic components of PLCs are there. So here one question is given as a digitally operating electronic apparatus which uses a programming memory for the internal storage of instruction for implementing specific functions such as logic, sequencing, timing, counting to control through digital or analog module is known as. Okay, so that is what we have talked about right now. So it's like digitally operating electronic device which is used to control and automate industrial processes. So it uses programming memory to store instructions for we can say implementing specific functions such as that is their logic, sequence, timing, counting as we have told, and like controlling. So to control that through the digital or analog modules, so that can interface with like variety of digital or analog modules for controlling and monitoring devices such as sensors here. So those are like that is the reason the that is called here. So the main the correct answer will be that programmable logic controllers, right? That is PLC. And now if we talk about input modules or output input output modules, so input output interface section, as we have seen in components of PLC. So if a PLC connects is to external field devices. Okay, so main purpose of input output interface is to like condition the various signals like received from or sent to the external input or output devices. But basically it like what it does, like it's like various signals received from like say send it has to send the external to the external devices, so it works as a connection between interface section. It is to like whatever the like various signals which is being received or which is being sent to the external devices, it does work as an interface in between that. So input modules convert signals from like discrete or analog input devices to like logic levels which PLC processor can accept, and output modules convert signals from the processor to the that levels capable of that driving the connected discrete or analog output devices. Okay, so that is how that input output module works. So here it is given as the question as fill in the blank provides signal conversion and isolation between the internal logic level signals inside the programmable logic controller and fills high level signal. So it is nothing but input output modules. We have seen how it works. So from that we can say that input output modules provide signal conversion. Actually that input modules convert the signal from input devices, that may be discrete or analog input device, to logic levels which is acceptable to PLC's processor. And what the output module does, it converts signals from processor to the levels which is capable of driving the connected discrete or analog output devices. So that is how input output module works. Okay. The next part is input module converts signals from discrete or analog input devices to logic levels. Yes, it is true, right? We have seen it. We have discussed about that. Then the next part is, so if we talk about that different types of input output circuits which are used here. So one is pilot duty outputs, then is general purpose outputs, discrete inputs, so analog input output. Those are the input output circuits which are used. So here pilot duty outputs, where so outputs of this type typically are used to drive high current electromagnetic loads, say solenoids, relays, valves, and motors, those are the things are used to drive high current electromagnetic loads. So these loads are highly inductive and exhibit large uh, inrush current. So that pilot duty outputs should be capable of withstanding an current of 10 times that rated load or short period of time. So this is that is about the pilot duty outputs. Then general purpose output is there. So that is usually low voltage and low current, and which is used to drive indicating the lights and other non-inductive loads. And if we talk about discrete inputs, that is that circuits of these types are used to sense the status of limit switches, push buttons, other discrete sensors. So analog input output, that is so analog inputs we can say it comes from devices such as thermocouples, strain gauges, then pressure sensors, which provides a signal voltage of or current that is derived from the process variables. So those are the basic input output circuits which are there. So one question is given as, sorry, which of the following is used to drive high current electromagnetic loads? So we have already talked about that pilot duty outputs designed to drive high current electromagnetic loads. So as solenoids, contactors, then relays, so starters, and these outputs can supply the necessary current to energize coils of these devices and switch them on or off, which is required. So that is how that pilot duty outputs work. So the right option will be pilot duty output. Okay. So those are the questions which I tried to discuss on that. like that week 8 assignments and like some overview I tried to give, that the questions which I tried to answer and explain. So that is all about that. Okay, one show sixth question. Yeah, sixth. Yes. In which of the following manipulator joints is used in translational motion? That is linear joint. Okay. And the last slide is okay. And here is the last slide. So, any doubt other than that? Anything else? Any confusion? Nothing? Yes, that is all about the today's week 8 assignment. So, any confusion is there? Anything else? We can leave then. Any confusion is there?